guys, welcome to the limiting reactant day of our unit. Basically, if you've gotten this far, this is page 7 and 8 of the homework. And that will be due next class period. But if you've gotten this far into stoichiometry, you actually know everything you need to know to solve this. These problems, the only difference is there's going to be two givens. They're going to tell you how much of both reactants that you have, and they're going to ask you to solve for the product. Of course, you need to balance the equation. So let's see, we've got 6 fluorines, 6 fluorines, and 2 aluminums. There's other tutorials on balancing if you needed more help on how to balance. So you'll see in each of these that we kind of prompted you to, or gave you enough room for 2 T-bars. You're going to need a T-bar for the 10 moles of aluminum, and you're going to need a T-bar for the 10 moles of fluorine. Now, every single stoich problem we do has that mole ratio step. I like to put an oval around it. So for this, every 3 moles of fluorine produces 2 moles of aluminum fluoride. And in both examples, we will be looking for moles of aluminum fluoride, and the coefficient of aluminum was 2. Now, this was actually an easier problem than what y'all are going to have later on in the exercises because this was a simple mole-to-mole problem. So 10 times 2 is 20, divided by 2 gives me 10 moles of AlF3. 10 times 2 is 20, but this time we're dividing it by 3. 20 divided by 3 gives me 6.6. And you're probably scratching your head going, well, what do I do? Add those together? Do I multiply? What do I do with these answers? It's actually very easy. Out of the 2 answers you have, the bigger one you will not be able to obtain, which means you're going to have extra or excess aluminum. So when it asks what the excess reactant is, we have extra aluminum because we have enough aluminum to produce 10 full moles of aluminum fluoride. However, we only have enough fluorine to produce 6 moles. Bottom line, the smaller of the 2 answers will be your final answer of how much can be produced. We would call the fluorine the limiting reactant because we will run out of fluorine after 6.6 moles of product are made. So fluorine produces the smaller amount of product, so it's what limits the reaction. You will do the same process for each problem. I'm going to go ahead and work one that's a little bit more complicated because I always hated in school when my teacher worked the easiest one and left us with the harder one. So I am going to actually work number 4. Number 4 is giving us 2 givens. It's giving us 33 grams of propane, and it's giving us 32 grams of oxygen. So we will set up 2 separate T-bars, one for the 33 grams of propane, as our given, and we'll set up another T-bar with the 32 grams of oxygen as my given. So we're starting with grams on both of these, and most of us know you cannot do a mole-to-mole ratio without being in moles. So the first thing we have to do is convert grams into a mole. So we have our C3H8 that we're going to convert into a mole. And we're going to have our O2, which we're going to convert into a mole. Now I do apologize for those of you who are used to using all the decimals for the demonstrative purposes. I'm just going to say that oxygen, when there's 2 of them, each oxygen weighs 16, which most of you know is actually 15.999. And I'm going to put 32 grams there. This one's a little bit harder to calculate. You've got 3 carbons that weigh 12, and you've got 8 hydrogens that weigh 1. So 36 plus 8 is 44. And now for each of these problems, we're in moles, so we can do our mole ratio step. Okay. So again, we'll have that mole ratio step where we compare reactant to product. And in the balanced equation up here, there wasn't a number for propane. So if there's nothing there, but there's coefficients on everything else, assume that the coefficient for that is 1. So for 1 mole of C3H8, we want to know how many moles of carbon dioxide are made. So I'm going to write, I should have made that a different color, sorry. We're trying to find moles of carbon dioxide. So for both problems, I'm going to write moles of carbon dioxide. And the coefficient of carbon dioxide is 3, so both of them will have 3 on top. And the coefficient for look at that. So after school today, you'll have to forgive me, but oxygen, 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 oxygen. The coefficient would be 5. So now we calculate our 2 T-bars. 33 times 3 is 99 divided by 44 gives me 2.25 moles of carbon dioxide. And then 32 times 3 is 96 divided by 32 times 5 So again, we look at our 2 answers. With this amount of propane, I can make 2.25 moles of carbon dioxide. But with this amount of oxygen, I can only make 0.6 moles of carbon dioxide. I will cross off the bigger of the answers because that would be considered an excess. We would have excess C3H8. However, what limits our production, what's going to limit us from making CO2 is going to be oxygen. So our limiting reactant is oxygen. We will have enough propane to make a whole lot more carbon dioxide than what we do with oxygen. So we call the propane the excess, and the oxygen would be the limiting. I'm going to go ahead and do one more on the back side. I'm going to do number 8 if you're still in there. Number 8 is going to be the most massive problem we could give you. It's almost mean that we put this on your homework. Starting with 35 grams of chlorine and 5 grams of hydrogen. And they don't want to just know how many moles, they want to know how many grams of hydrochloric acid is produced. So, this is 2 gram to gram problems. We're going to have to convert our grams of chlorine into moles of chlorine. We're going to have our good old mole ratio step. To find our moles of hydrochloric acid. And then not only that, we're going to have to convert a mole of HCl into grams of HCl. We're going to mirror this process for our other given. Our other given is in grams as well. 5 grams of hydrogen. So we'll put grams of hydrogen here. That's a mole of hydrogen. Here comes our good old mole ratio step here for moles of hydrogen. And then we will have moles of HCl, mole of HCl, and grams of HCl. Okay, for this, there's 2 chlorines that weigh 35.5. There's 2 that weigh 35.5. So I'm going to round that and just put 71 here. And that's how much 1 mole weighs. Now, I forgot to balance the equation, so I hit the part where I need the coefficients, and I realized I didn't have any. So this one is actually a pretty easy one to balance. For every 1 mole of chlorine, 2 moles of hydrochloric acid are produced. And then every 1 mole of hydrochloric acid, there's a hydrogen that weighs 1, and there's chlorine that weighs 35.5. So that's 36.5 for the mass. And honestly, if you've already done it for one problem, all the stuff on the product side is going to remain the same from here. So we're starting with grams of hydrogen, so we need the mass of 2 hydrogens. And as some of you know, that is 2.016. I'm just going to put 2 there for now. And hydrogen has a coefficient of 1. So our T-bars are set up to completion, and it's time to solve. 35 times 2 times 36.5 gives you 2,555, and we're going to divide that by 71. And you get 35.98 grams of hydrochloric acid could be produced. 5 times 2 times 36.5 gives me 365. We're going to divide that by 2, and 182.5 grams of HCl could be produced. So out of those 2 numbers, we will never obtain 182 grams of HCl. So that means we have extra hydrogen because we're going to run out of chlorine after 35 grams of hydrochloric acid are produced. So our final answer would be you could produce 35.98 grams of hydrochloric acid. In sig figs on your test, it would probably just say 36 grams. And that would give us our final answer. This will be the end of stoichiometry, so tomorrow's notes will have no T-bars. So there is a little bit of light at the end of the tunnel here. And hopefully this has helped set up your problems and given you a perspective on how to solve for limiting reactant. Thank you.